Next, let's create a ciphertext with a Caesar cipher. We will explain cryptography in more detail in the next part. Here we will consider how to encrypt a message to make a ciphertext. What exactly is a Caesar cipher? Caesar was a famous emperor in Roman times. That Caesar is said to have devised this cipher. In this cipher, you can create a ciphertext by shifting K in the alphabet for each letter of a given text. Note here that K must be kept secret. That is, it is a secret parameter. It's a way of creating a cipher by doing a shift of K. For example, let's consider here what happens if K is 7. To keep things simple, here we will apply the shift only to lowercase English letters. In other words, if we do a shift of 7 letters for this string, goodbye, if we encrypt it with a Caesar cipher that does a shift of 7 letters, we will get this sequence of characters. So what exactly is a shift by 7 letters? For example, B corresponds to I. Starting from B, the following letters are C, D, E, F, G, H, I. You see, I is the 7th letter from B. Therefore, B corresponds to I in the 7th shift. Likewise, C corresponds to J, and the D corresponds with K, and so on. We need to take care with, for example, a letter Y. Let's start counting from Y. After Y is Z, and then this is the last in the alphabet. Then we need to return to A. Therefore, continuing with A, B, C, D, E, F. And so F is the 7th letter from Y. Okay? Likewise, with X, we have E, which corresponds to the X, which is one letter before F. The idea of this shift the idea of this correspondence goes like a cycle in this way. Using this idea, let's take a good, for example, then corresponding to O, we have B, and then D corresponds to K. Okay? So this becomes good, becomes this sequence. And then goodbye becomes this sequence. Here, please note that G is not changed because it is uppercase letter. Likewise, this exclamation mark is not converted either. Here we only converted lowercase English letters. Let's name the program for doing this encryption as enc.rc. That is, it executes like this. Okay? And when it is executed, it expects us to enter a string. So we enter, for example, goodbye. And then, as you can see, it is converted this string, which is output as the result of this program. Let's make this kind of program. Okay. First, consider the idea. To keep things simple, let's consider converting only 3 letters, got, which should be converted to this, GVK. Let's consider the steps. First, we will put God in an array, a character string. Let's call this array M. Next, we will convert it into a character code. We will convert each letter into ASCII code. Let's use an array A for keeping the code. Then we will shift it. The uppercase letter G is not shifted, but with lowercase letters, the code for O is 111, so it shifts by 7 and places to 118. And then since the code for D is 100, shifting it by 7 places, adding 7 gives us the shifted value 107. Then by turning these obtained numbers into characters again, a ciphertext is created. In terms of the program, you can use unpack to turn the character string into code. Also, after the code of the ciphertext is obtained, this sequence is obtained, we can simply use a pack to get it a string, which is the desired ciphertext. Then the most important part is this computation, that is calculating the code by k-shifts. We will consider this part later. So this program does it in practice. Let's take a closer look from the first line. As we saw before, it's convenient to memorize the code for a letter A, that is 97. Okay? So let's put it in this variable. Then we use the variable k to keep the shift value. Let's use 7 in this example. Note that this should be kept secret. This is a secret of the people using the cipher. Now, move on to the third line. Here we read the string that we wish to turn into a ciphertext. The command for that is get.chomp. Okay, let's put what is read into array m. Then we can measure the length with this statement and put this length of this variable m or array m into len. In the fifth line, we prepare the array b. I explained this command before. This is a command to create an array with specified length. In this case, the len is specified length, which is the length of the array m, which is the length of the input. For example, if our input is God, then this is 3. Let's set the initial value to 0 for all boxes. In this way, we will put the array in a place named B that provides us with an array to start with. Then we follow steps that we have just discussed to create and output the ciphertext. As I mentioned, the key part is to compute the shift by k. We will consider this computation with a practice exercise. Let me summarize what we have done. In this part 2, we studied characters and strings. A string is an array of characters. It can be handled the same way as a normal array. Furthermore, in many cases, it's convenient to transform characters into a character code. This lecture used the global standard character code called ASCII. ASCII assigns ordered values to lowercase a to z or uppercase letter capital A to capital Z. As a side note, we just saw a number of times that ASCII of A is 97. Finally, let's go over one more time how to write in Ruby, in particular, commands on strings. As you can see here, we wrote a string enclosed by quotation marks, which can be set to a string variable or an array of characters as an initial value. Another way to set the initial value is to use an input string, where we use gets.chomp to read an input string. A string is an array, so we can manipulate it like we manipulated arrays, standard arrays. If we write dot length like this, after the name of the array, it will tell you the length of the array. We can keep this length information by storing it into a variable, in this case, a length. Typical commands for strings are for converting from a string to its code and its code to a string. First, using unpack. Okay? Unpack command, in this way, we can get the code of a string in the array S. And then this can be put into an array A by this assignment statement. On the other hand, by using unpack, we get a string corresponding to the sequence of codes in the array A, which goes into the array S by this assignment statement. This concludes the summary of the basic commands involving characters and strings.